Okay, in this tutorial, we're going to have a look at amino acids and we're going to look at what they are and what constitutes an amino acid. So let's look at a simple example of an amino acid to start off with. And to start off, we're going to take a quick look at quite a simple amino acid called glycine. Now, glycine has, well, I'll just draw it out. And then we'll take a look at what functional groups glycine contains, and then after that we can see I'll draw out another amino acid and we can see what is the common factor in terms of the structure. So this is glycine, so so that is glycine. In fact, let's another colour to write that out. So GLYCINE, and it can be abbreviated to just GLY. There you go. So that is glycine. So if we take a look now, what functional groups are here? Now, if you can't remember what functional groups are, you need a reminder. There'll be a link in the description, and I'll put a link up on the screen as well. So if you note here, we've got an amine group, which is NH2. And over here we've got a carboxylic acid group. Now over here there aren't any other functional groups, so it's the NH2, the amino group, and the carboxylic acid group. So if we draw out another example of an amino acid, this is alanine. I'll write the name down first this time. Alanine, and the structure for this is CH3, CH. No, sorry, that is wrong. I apologize. Delete that. No, let's get an eraser, might be a bit easier. There we go. The H is up here. OH. Then you've got the NH2 up here. Okay, so again, we have what's similar between these two amino acids. Well, first of all, we've got our amino group here, the NH2. That's in terms of functional groups, and we have got a carboxylic acid group here. Now, the middle bit's slightly different. We've still got a hydrogen here, but our bottom bit here, or the top bit, whichever way you look at it, is different. Because bear in mind the molecule can be switched over, and the CH3 can be at the top there, and the hydrogen can be at the bottom for the alanine. So the main similarities is we've got one carbon in the middle, we've got a carboxylic acid, an amino group, we've got a H group, or a hydrogen off the central carbon, and we've got some sort of group here. So if I just move that up there, so the base of a amino acid, if I just draw out an amino acid base, is you've got your NH2 here, so NH2. You've got a central carbon, you've got a hydrogen coming off, it could be top or bottom, it doesn't matter because it can be flipped around, and you've got your carboxylic acid group over here. Now, the only thing that's different is one of these groups here. So here we've got another hydrogen, here we've got CH3, and you can have loads of different groups like, for example, you can have things like benzene rings, you can have longer hydrocarbon chains and stuff like that. But in terms of the base, we've got an R group here. So that can be some form of group, whether it be CH3 or now R can equal, just as an example here, in glycine, R equals, in fact, let's call it Rn, just to make it a bit simpler. We've got hydrogen, just simple hydrogen, Rn as in anion. We've got CH3, and some more examples are things like this. So that would be joined on up there, or yeah, and that is valine or valine. And we've got other examples. For example, you can have R can equal Rn can equal have a benzene ring on it. For example, this is phenylacene, or PHE for short, but basically off the central C here, Rl would be CH2, and then you've got your benzene ring here. So drawing our double bonds like that, and so you can have lots of different groups of the amino acid. But what constitutes an amino acid is it has got this base here, and it's got a amino functional group and a carboxylic acid functional group.